Welcome to EDU World Space.
Welcome to problem number 23.32 of chapter 23 electric potential. So we are given that there is a long insulating cylinder here and this carries linear charge density which is lambda here and the value is 15 nanocoulomb per meter. So nano is 10 to the power minus 9, so this becomes 15 10 to the power minus 9 coulomb per meter. The radius is given, we have 2.5 centimeter, so which means that 0.025 meter. This is a very small radius. So this charge is a positive charge. That means whatever the charge resides on this road is just a positive charge. So let's make some positive charge here. So the question says if we measure the potential difference between a point from this point, let's say we have a point some, and from the surface, and another point is on the surface. So the potential difference using voltmeter, we should have 175 volt. So this is the potential difference between this point and the surface point. So we have a formula here which we will use to find out the d distance. So d prime is the distance from our center of the road. So this is the point where delta v is 175 in respect of the surface point. And d prime is the point from the center of the road. So this is the center of the road. So therefore d prime minus r is equals to d. So this is what we have to find out. So we need to find out d. So d is the point from the surface. Point from the surface. So we will calculate this d or d prime first using this formula. So delta v is equals to lambda by 2 pi epsilon naught logarithm of rb over ra. Rb is the distance from the center of the road to the point, and r is the center. R is also at some distance from the center of the road to some other point. So let's say we have a here and b here. So these have distance from the center. So we know that d prime is the distance from the road, and r is also the radius, which means the radius is from the center of the road towards the surface. So we will use this formula to find out the value of the d prime, and then we can find out d. So this becomes rb equals to ra exponential 2 pi epsilon naught delta v over lambda. So just taking out these terms on the left hand side. So we have, let's solve this equation. So we have rb equals to ra exponential 2 pi epsilon naught delta v over lambda. So we know the potential difference between surface and this point, which where we have to find out the distance. So we will use this ra as the surface here. So this becomes capital R, and this becomes 2 pi epsilon naught. Delta V is our 175 volt over lambda. Lambda we know that. So use your calculator to find out the value here for the RB. So this becomes 0.025 meter into exponential factor and 2 pi epsilon naught. We know that finding out the value of 2 pi epsilon naught, we know that 1 by 4 pi epsilon naught is equals to 9 into 10 to the power 9. So This becomes 2 into 9 into 10 raised to power 9, which is equals to 2 pi epsilon naught. So placing this value here, let me write it again. So we have 0.025 exponential 1 over 2 into 9 into 10 raised to power 9 into 175, and lambda is our 15 nanocoulomb. So we put the value here. So 15, sorry, this is 1 point. Let me check again. So we have 50, yeah, it's right. It's 15 nanocoulomb. So this becomes 15 into 10 raised to the minus 9. That's it. So using calculator, you can find out the value here. So this becomes 0.025 exponential 0.648. Use your calculator again. So we have 0.0478 meter or 4.78 meter. So we have this road. So we have find out this distance, and we know this is r. So the distance from this surface to the point, so this is d. So this is d prime. So here this rb is your d prime, this d prime. So your d becomes d prime minus r, or rb minus r, because rb and d prime are same. So this becomes d equals to d prime minus r, which is equals to 4.78 centimeter minus 2.50 centimeter, which is equals to 2.28 centimeter or 0.0228 centimeter. So your d from the surface is equals to 0.0228 meter. So that's your answer finally. You can look it again. So this is our first slide, and this is our second slide, and this is our third slide. All right. I hope you have understood the answer.